Hi there, my name is Austin Dial. It's January 29th at 11:11 p.m. The only reason why this is 50 minutes or 40 minutes or so away, pardon me, from the assignment time is because I just discovered one last error, and so now I need to re-record this submission video. Nonetheless, this is my video demonstration. I always like to include these with my assignment submissions, just in case something gets lost and they're like, oh, maybe he didn't do it, just to kind of prove that I did. This is my demonstration for assignment number 1. I'm just going to run it directly from my terminal here. I added an extra feature. I should like to mention that this program does go above and beyond the actual requests and specifications of the problem statement. It's better. It gives you the resistor network itself, which is nice because if you're really going to plug in these resistor values and it's going to give you an output, it would be nice to know what the circuit looked like, right? Because otherwise, how are you going to analyze it if you don't know the configuration between, for instance, R3 and R2 are parallel, but R3 and R4 are not? How are you going to know the difference? Well, it prints it for you. So we'll just start by demonstrating the actual values that were given in the example. Okay. I added even more. Not only does it give you the equivalent resistance of the network, all of this was required by the problem statement. It gives you the correct output. But on top of that, it also gives you background work, and it shows, well, I took these as series, these as series as well, and then I took each series as parallel, and I got this equivalent resistance. This is nice, just not only for a debugging standpoint. It was very easy on me to know, well, what exactly is it doing? Is it performing the calculations correctly? But it's also nice because it's educational, like how does this work? How is it analyzing it? And how do I know that the results are accurate? On top of that, I ran it in a loop. If somebody's really going to use something to analyze resistor networks, maybe they want to do it multiple times without entering into the same program. If they want to exit, they can just hit enter after typing E, or they can pass the character C into the scan F, and look at that, it just starts over again. You may have noticed these 3 trailing zeros. I'm using the float type, which means that I can enter like things like this. It also makes it a lot easier because when you're looking at actually debugging it, when all of these are 10s, you don't know which 10 is what. Whereas when you have different values, this stuff really comes alive. So let's make it come alive. Oh. There we go. So as you can see here, it handles all of the float. It passes all of these values correctly, giving us this output, and gives us the final equivalent resistance. Looks like this guy ran beyond the screen window, so it just printed it to the new line. Typically that wouldn't happen, but I did enter pretty large values, particularly right here and right here. Anyways, I'm just going to exit. There we go, look at that. And now we're exited. Once again, it's 11:14 now. Guess like this video ran a little bit long, but I hope you enjoyed. And in the event that you did not see my submission via the forward from Professor Mia just earlier this evening, once again January 29th, this video might be able to help you out. Anyways, thank you. Good luck with your grading. I know that it must be pretty difficult to be probably a graduate or a senior, maybe even a junior, and still have grading on top of that. But I wish you all good luck, and I hope that's helped. Thanks. Bye.